Hey, hi everyone. So welcome back to our another session in our ongoing series, and we are thrilled to have Whitney with us again. For those who are meeting her for the first time, she's the founder of Engage Prep and has helped lot of students preparing for GMAT over last multiple years, I would say. So she helped us tackle one of the interesting, challenging areas previously on the assumption questions around the hard questions. Those who haven't joined us previously, you can check the link in the description. And today we are gonna tackle one of the implicit quant concept, I would say weighted averages. The conceptually it seems quite simple when you look at it. But when you see the question, it's always quite difficult to understand that, okay, this is kind of one of those weighted averages question. So today she will help us kind of identify few of those things as soon as we see the question that when do we implement weighted averages and what's the best possible strategy. And feel free to drop your questions in the chat whenever you have any. We will take those up. We'll have enough time at the end of our discussion. We'll try to answer as many as we could. And with that, over to you, Whitney.
Thank you so much, Harsh. Hi, good evening to everyone. Good morning to my US based folks and anyone abroad. Good afternoon, good evening. Thank you. Again, my name is Whitney, founder of Engage Prep. I've been at this game for like 20 years, which sounds crazy to me. But I'm actually really excited about today's lesson on weighted average, mostly because weighted average questions can be very easy, as Harsh said, they can be very, very easy to solve. But we have to be able to recognize them. And I think the bigger thing, especially with the new GMAT focus, I don't know if y'all have started to notice this on practice exams or for those of you that have taken official exams, that the GMAT focus seems to be expecting us to do a ton of computation. And kind of ugly computation. The numbers are much less lovely than they used to be on the old GMAT. And so that can make us think, wait, why are we doing all of this computation without a calculator? This is insane. But it's because I really think that the GMAT focus is leaning into hoping that people will use strategies that help them avoid the computation, avoid the algebra. It makes it more of a scrappy, I'm going to business school, I'm not a mathematician kind of test. So I wanted to take a look. I think it becomes even more imperative that as we see these questions, we recognize them for weighted average because there are some really phenomenal shortcuts that we can take, visual approaches that we can take that really just wipe out the ugly numbers that the GMAT sort of throws in our face. So not sure if y'all can see my screen. Hopefully it is up and showing. I think right now it's just me and Harsh's beautiful faces. There we go. Okay, beautiful. And so what I'd love to do is I'm going to give you two questions side by side. And I just want you to try them. I'm not saying they're one or both weighted average. I'm just saying here's a couple questions. I want you to try them in either order that you'd like. Feel free, and then we'll chat. So I'll give us about 4 minutes, right? So it's probably gonna be a little tight on a couple of these, but I'll give us about 4 minutes to give them a shot, and then go ahead and chat in when you think you've got an answer. And while you're working, maybe chat in where you're located because I'd love to know. All right, so we're just over the 4-minute mark, and I'm not seeing a lot of answers coming in, which doesn't surprise me. So, what I'd really love to see though is your thoughts on these. Are either of these weighted average? Do either of these feel like an average? I mean, I certainly see the word average in one of them, so maybe that makes it an average. Um, okay, the lawyer. Okay, we've got some guesses on the lawyer one. Not sure for the dealer one. I feel that. Thank you. Redicted. That's amazing. That's a great username, by the way. Although it should be GMAT Club Redicted, but whatever. Either way, that's all I'm saying. Any other ideas? So I've got a guess on the lawyer problem. This is good. This is fun. I've also got a quiet group this evening. What about you, Harsh? Do these feel like weighted
I
average to
think
you?
second one was definitely weighted average. That
Okay,
seems
second one.
direct. But yeah, first one I ended up going via the algebraic route.
Oh, okay, doing a bunch of algebra. Fair. Yeah, you're like, I went and did a bunch of algebra. Super. Exactly. So I think, yeah, and this is a great. Redicted said a great thing. I have trouble identifying weighted average. So here's what I wanted to do. I wanted to take a little step back. I wanted to give you these two, and then we're going to see them again, right? But yeah, I think that often if a weighted average is really, really, really straightforward, okay, fine. But there are a lot of ways that the GMAT is going to disguise weighted average, and it's in those examples that's like the moment we want to be able to use weighted averages the most. So I want to back up just for a second, and kind of get this idea. Yeah, it's like I got 18% profit in the first one. Like, how did I do that? I got 16. That wasn't an answer. How did this happen? And you probably did a bunch of math without a calculator, right? So let's start with just basic weighted average, right? So let me give you a problem that is for sure a weighted average, and let's talk about what weighted average means as kind of a concept, right? So question on the screen. I've got some employees at a company earning different amounts of money, and then I want the combined average. Like, this is the real, like, quintessential weighted average archetype, right? Like, this is the basic. You've got some metric that you care about. Maybe it's income, maybe it's height, maybe it's the weight of something, like the literal physical weight of some boxes. It's the price of things. It's the GPA. It's the cost of a product. So you have this metric, cost, salary, height, whatever, and you're getting that metric for two different subgroups, but you're also getting that metric when those groups are combined into one mass. Like, that's the quintessential, like, skeleton of a weighted average, that we take a big blob of things, people, boxes, students, whatever. We take this blob, and then we say, hey, there's this metric we care about for everybody, but there's two MECE, what we call mutually exclusive, collectively exhaustive groups inside. We can cut this into two parts. And if we cut this into two parts, that metric is maybe different for each of those two parts. Okay, so when we're solving a problem like this one, we might just reach for the weighted average formula, right? Like, that's not uncommon because the weighted average formula is pretty friendly. The more generic, just so we kind of have it here, I'll toss it up for you. So the weighted average formula is this kind of sum of, we got a little bit of twitchiness. My apologies. Hopefully it'll stop for me in a second. Here we go. So we've got this formula where basically what we can do is we can add together each subgroup's average times like how big it is, its weight, its size, right? And that seems easy enough in a lot of cases. It's really easy if we have a calculator. So in a problem like this one, my weighted average is the thing I'm solving for. I've got 12 employees. That's a quantity. That's my weight for my first group. So I've got 60,000 at 12 employees. Plus, I've got 80,000 at 4 employees. And then I want to find that whole salary for the 16 employees total. Is this math the worst? No, it's not, right? I can find 4 times 8 and 12 times 60. I can do some simplification. But let me ask you this. Let's say I changed this story a little bit and I said 8 employees made 60,000 and 4 employees made another 80,000. What's the average for the 16? Or sorry, not 8. This is 8 too. Both of them are 8. So what if I had 8 and 8? 8 employees made 60,000. 8 employees made 80,000. What would the average for my 16 employees be?
Yeah, it would be 70,000. Yeah.
Yeah, it'd be 70,000. It'd be right in the middle. Because the thing with a weighted average is if all my weights are the same, it just devolves into a standard average. And so for most of these problems, there'll only be 2 groups. Technically, you could have 3 groups, 4 groups, 5 groups, what have you. But for most of these, there'll just be 2 groups. And if we can recognize that if those 2 groups were the same size, the actual numbers wouldn't matter. Like, it doesn't matter that it's 8 and 8 or 12 and 12 or 29 and 29, like miserably ugly. We sure are. You're going to solve them better than we did, I promise. So these 8 and 8, that they're the same. What we can really start to see is that weighted average is a game of relative size, of ratios. So this is often why you might see these like allegation tables getting used or people talking about these little tricks for thinking about the weights. Because one of the things that the GMAT can do to make these questions really ugly is give you ugly weights. Not that 12 and 4 are that bad, but 12, 4, and 16 aren't my favorite numbers. What I could think of instead is that a ratio of 12 to 4 to 16 could still be reduced, right? So if I have my ratio of 12 to 4 to 16, I can reduce all of those by 4, 1 to 3 to 4, and now I could actually use much more simplistic numbers, even just in my algebra. So step 1, at a minimum, even if you are a devotee of algebra, the thing I want you to start to see, and that's why I gave you this kind of simplistic one, is that weighted averages is really a ratios concept. It's a concept of which group is bigger or smaller by what amount. But if we really want to save effort, we need to start to switch to a more visual approach. And you may have seen these. A lot of people talk about them with like teeter-totters and, again, this like allegation method. I have a method that I really like that I think of as a tug-of-war. If you think of the rope game, right? So are you familiar with that like rope game where there's like a little flag in the middle and you have 2 teams on either side and they're like pulling? So a visual approach here is such that you'd say, okay, I have my 12 employees over here and my 4 employees over here. Just like in the fraction, I'm going to keep my weights on the bottom. And up top, I'm going to put the thing that I'm mixing or averaging, that I'm bringing together. So I've got 60,000. I'm going to drop all my zeros for a second. And then I've got 80,000 over here. Now, these weights, if I can see them as being proportional, this is the same as a 1 to 3 ratio. That means that my 80,000 has a power of 1. My 60,000 has a power of 3. My 60,000 is stronger. So without doing any math, okay, so first things first, without doing any math, if I have a little flag on the field, right, we're playing our little tug-of-war, right, so I'm going to put a little flag in here somewhere. Where would you put it? Closer to the 80 or closer to the 60? What do you think?
I would put it closer to 60 because of.
Well, 60 is stronger. Yeah, our 60 is stronger. It's pulling at a rate of 3. And so when I like to think of this strength, right? When I think of this strength, I'm thinking of the fact that 60 has the ability to pull 1, 2, 3 in its direction away from the 80. 80 only has the power to pull 1. So at minimum, I could look at my answer choices and say, look, I know the answer is going to be closer to 60. I know that for a fact. But I can get actually quite specific. This number line, right, between 60 and 80 is going to get divvied up into 1, 2, 3, 4 chunks. 3 chunks towards the 60 and only 1 chunk back towards the 80. So if I divide those 20 by 4, each one of these little pull chunks is like 5. And so I can get to the math by either, adding 5 on this side or subtracting all of these 5s on this side. And so my actual average here would be 65,000. Is that a lot faster than the algebra? I would say in this case, maybe. Okay, in this case, maybe. So when is it going to be faster to use this visual, right? Because that's the part for me that's always like, okay, when's this going to be faster? So I've got my weighted average formula. It's always usable. As long as I know I'm in weighted averages, it's always usable. Either have lots of different averages or just the two, and then plug in and reduce your weights. But this tug of war, right? This tug of war where my metric of interest goes up at the top, my weights or amounts go at the bottom, it lines up with my weighted average. The thing I really like about this is two things. One, it's going to let me visually see my two groups. It's going to let me make some estimations. It's also going to make the math a whole lot faster in some very specific situations. So if what is missing is, and so I'll give it to you here, sort of here. If what is missing is this middle combined value, if that's the thing that's gone missing, then you're fine either way. I think the weighted averages formula, an image, whichever, totally fine. However, if what is missing is one of the details about the subgroups, so you're told what the weighted average in the middle is, but you're missing some of the ones on the side, then it gets a whole lot easier to deal with the image. So let's try one. A little bit more complicated. Feel free to stick it in the algebra, and then we're going to take this one and start to head back to the two that were on the screen because I want you to be able to see those. So let's give this one a go. Feel free to try it with a formula. I'll kind of sketch up what I make this little over-under look like. This might be my, juniors and my seniors. But try it with a formula and sort of tell me what happens. We'll take, I don't know, a minute and a half. And as you're giving me an answer, I want you to let me know, how was the algebra? Fine? Mostly okay? Harsh with the mental math. Yeah. Yeah, I'm getting a variety of answers. So, yeah. So how is the math on this one? Okay. Are the numbers acceptable? What did you try? So Harsh, chime in. What did you try for this one? Formula?
I just try to juggle the numbers like 26 and 78. It's 1:3. That makes the whole logic simple. If you minus 69 minus 65, that again comes up to 4. So 3 plus 1, 4 by 4, 1. So it's 1:3 kind of a thing. So 66 comes out.
Beautiful. Yeah. So with some mental math, we can still get there. And so just to kind of see the way this might work kind of more visually, if what I'm looking for is, again, this like combined, what's the average height of the juniors and seniors combined? If I've got, right, my more formal would be something like, I have 78 juniors at 65 inches each. God help me, that's ugly math. And I've got 26 seniors at 69 inches each. And I'm going to divide that by the 78 plus 26. They're going to trap a bunch of people in some really ugly longhand computation. But if you can notice the same thing Hirsch did, which was like, hold on, 78 juniors is to 26 seniors. Okay, maybe you didn't see that 26 goes into 78, but they are both even. So at minimum, you could have reduced them, right, into 39 and 13, at which point you absolutely should see the ratio at that point of 1 to 3. So at a minimum, that's going to make my math a whole lot easier, right? I've got 3 into 65, 1 into 69, and I'm going to divide that whole thing by 4. Let me show you, though, what this might look like on the same concept if that kind of mental math doesn't always kind of click for you, because it doesn't always for me in the middle of a stressful test. So let's say I've got my juniors, I've figured out this, I started with my 78 and my 26, and I figured it out that this was a 3 to 1. I've got my poll 1, 2, 3 coming this way, 1 coming that way. My juniors have a height of 65. My seniors have a height of 69, which just so happens to be a 4-point spread, which exactly lines up with my ticks, which isn't surprising for the GMAT. And so each one of these little tick marks of jump that I would have done would have been 1 point each. That's going to be 66. Wow, that handwriting is terrible this morning, but that's going to be 66. And so even if the kind of mental, like keeping track of those numbers in your mind is a little hard, the visual is there to kind of help you organize it. Right, help you kind of put it in place. So now imagine that what I've got is a part where something is missing, right? So now one of my edges is missing. Let's go with, here we go. We can try this little guy. Let me erase this so we can have some space so we can see the two together. I'll just drop this one in for us. Here we go. So give this one a go. A little bit prettier numbers. How do we set it up? And then shoot me your answer when you think you've got it. Easier? Harder? Same? What do you think? How did this one feel compared to the other one? Was it as easy to kind of like quickly move through? What do you think, Harsh? How about you, our mental math expert?
I think it's a bit tough, but yeah, if you know the concept, you can still do it. Like 85 minus 8, it gives you 5. It's like 6 into 5, 30. 30 is you are in deficit. You need kind of an increment of 30 on your remaining 4 quizzes. That's like 30 by 4 is 7.5, which is 85 plus 7.5, it's 92.5.
Beautiful. So we could do this with the formula, right? The issue, and it's not so bad here, but we'll fill it in. This time we know that the average is 85, and we've got 6 quizzes at 80, plus 10 quizzes at some unknown amount, all divided by the total for 16. And then once again, I would probably reduce this, right? I would reduce these to divide both by 2, and I'd make this a 3 to 5 reduced by 8, because 8's nicer to divide by than 16, or 8's nicer to multiply by. So if you're doing this with like the full formula, fine. But I think to Harsh's point, if we can start to see the actual like how these two pieces work together, same idea. So I just like to have it on paper so my eyeballs can help me out. And so in this case, I've got my first 6 quizzes, and then my later 10 quizzes at some unknown amount. My average is an 85, but before I kind of plug that in, Notice that I'm going to, now that I have these weights, this would be a weight of 3 to 5. So I need to separate this by 8, like right, my 8 pieces. So I'm going to pull 5 this way, 1, 2, 3, 4, right? So it's 1, 2, 3, 4, 5. And this one's going to pull 1, 2, 3 in that, other direction. Let me get this guy out of the way. So 5 is going to pull away from the 80. 1, 2, 3, 4, 5. I need more coffee this morning. And then 3 is going to pull away because this side's only 3 strong. And then I've got to figure out if this number is going to be 85, what's each one of these things worth for me? Right? Like how much is each one of these going to be worth? And so I think I've got my little drawing all sideways. But yeah, I've got my 80 on 6. Oh, 10 quizzes, excuse me. This is 4. That's why my math is crazy. Thank you. So this is 4. And so these ratios, man, some mornings my mental math is nowhere near as fast as yours is, Harsh. And so this one is 2 over 5. Or I could keep it over 10 because 10 would be nice math here. So let me kill this guy and try him again. We've got a 2 and a 3. Yeah, misread for me too. And I wrote it, so that says something. So I've got this list over here. So I've got 80 on one end, and I've got the unknown over here. I've got first 6 quizzes this side, then total of 10 quizzes. I got the 4 over here. So I can just leave it as 10 if I want, or I can reduce it to 5 if I want it to be a little bit shorter. So I can have 1, 2, 3, 4, 5, 6, 7, 8, 9, whatever. This one pulls over 1, 2, 3, 4, 5, 6 of them. This one pulls 4. That's where my 85 is going to be. I've got 1, 2, 3, 4 to get me to 85. And so I've got 6. So 5 versus, right, so my 4 versus 6, I've got to go 50% more. So I've got to go, if this side is under 5, this side is going to be up 7.5. And so similar. It's like finding our ratios. So let's look then at the problem that we did earlier on and see how we can use either of these methods to solve the lawyer one, right? So let's start with noticing that even if it's kind of like price per hour, it's still a weighted average. If I were to sort of sketch this out, I've got $3.75 is my hourly rate for one, $2.25 is my hourly rate for the other. This time I've been given the middle number at the top, but nothing about the 2 bottom. Right? I don't know anything about these 2 numbers down here. But I do know that the number in the middle is like 285. And so I can look and see how far 285 has been pulled from each end. This is where I do think the pulling back and forth, where the stuff missing are the weights, is the most powerful. So 285 is pulled 90 away from the 375 end. And so this is client meetings, and I'll just not, this is document preparation. 225, the 285 is pulled 60 away, which means these are in a ratio of 9 to 6 or 3 to 2, which means client meetings are, this is a ratio of 2 to 3 out of 5 total hours. My client meetings are 2/5 or 40%. I can certainly get there with algebra, but now I've got 2 unknowns. So I'm going to have 2 variables here of an x and a y if I want to do it with a formal algebra way. So we can start to see this as more of, okay, well, how far did we pull from one end? How far did we pull from the other? And that allows us to use more of the mental math, right? Just as we saw, like Harsh's like lovely mental math. We're able to use more of that mental math and not have to do as much computation. So then before we jump into some Q&A, and I just wanted to show you some other examples, we still have the second question, or technically it was the first question. And so I want to know if now that we're starting to see like 2 subgroups combined, right? If we've got these 2 different subgroups and then something about them combined, is this, laptop problem maybe about weighted average? I don't know. So let's take a look at it again. I'll put another minute or so up so you can try. Yeah. And I want you looking for, okay, well, what is the concept that, or what is the metric for each subgroup? What is the overall metric? And then you might even realize that there is a number that we don't even need to use. Okay, so is there a metric that we have two subgroups and then the combined group all interested in? What might that metric be here? I always look at what they're asking me for. We want the dealer's profit or loss. Do I have profit or loss for the laptops that I sold? I do, right? It's 25% profit. Do I have loss for the laptops that I had to return? I do. It's a 55% loss, which means I have profit and loss metrics for the two groups. I don't even need the 900. I never have to come up with what original pricing was. I never have to back out what 75%, or what would have taken me up 25% to get me to 900. I can literally look at this and say, okay, so again, I'm going to use my visual because it helps just me see what's all happening, even if that's not the way you draw it out. But on one end of the spectrum, I'm making 25%. On the other end of the spectrum, I'm losing 55%. Just as a heads up, that's a spread, right?
45% or 55%? Yeah.
What is it?
Will it be 45%?
Sorry, 45%. Yeah. Okay, so 45%. Here we go. Thank you. Right? And so I've got this loss of 45%, gain of 25%. So 55, 65, right? So I'm up to 80, my spread of 80, right? Ticked across. Okay, I've got in this stack 45 solds, in this stack 5 solds, which is a ratio of 1 to 9, which means this thing pulled it 9 its direction. This thing pulled it only 1 its direction. Right? And so I've got this, I've got to subtract my metric off here. Each one of these things is 8. Oh, and so I think I have a typo. That would be why. And so each one of these is 8. And so I've got to my actual average is going to be a profit of 25 minus 8, which is that should have been 17 up there. And that's there we go. There's my people. Beep. Ignore me. That is why it's so early this morning. So I'll make sure that before you post it, Harsh, fix the number. My lovely patient friend. But I've got this 8%, right, off of my 25. I only have to move 8. I just can't do math in the morning. And so I can do that without ever having to figure out what the original prices were for anything. I can figure it out, that number never comes into play, and then I can just live inside these percentages. So yeah, so one of the things I want you to think about here is if I can see certain things as weighted average. Oh, sorry, it is A. Okay, was I right? I was right. Okay, thank you. I thought I had my numbers right. I just couldn't do math right. Is that right? Because that's 55%. Hold on. I was like, did I get a 55% refund on my cost, right? Which means I only lose, yes, I only lose 45. So that'd be 55, 65. That's 80. No, it's 80. It's still 80.
It's 70, correct?
Is it really? 55 plus 25?
It's 70.
Oh, it is minus 45. You're right. It is 70. So my math was right when I was, or no, it wasn't even right then. My God. My math was so bad. Holy cow. Crew, we're doing this together. So, ignore me. So yeah, we're down here to 18. I'm coming off 7 from each one. Math in the mornings is not my thing. This is why I don't take the exam at 9 a.m., 8 a.m. All right. So thought, though, is that if I can actually do the math right and not have a typo in my problem, he gets 55% back. So he only loses 45%. Yep, he only loses 45%. Yes. So how do I recognize weighted average when presumably there aren't typos, ideally? There's really, most of these two metrics, the basic metrics like we saw in the first questions, but there are 3 common variations that the GMAT loves to kind of hit you with. One is this profit loss, right? So this is our dealer's profit loss. That is, and this one's like an even different number. That's probably why there was a typo in one of my slides because I kept changing numbers. And so we've got profit loss is one of them, but mixtures and even job completion. So my folks who've been pouring through the official guides, if you remember that Terry problem where Terry's trying to read some books, that is also a weighted average problem. And so with mixtures, I'm thinking like 40% zinc and 10% zinc, right? To get this mixture of 25, I can just sit in the percentages, right? Or if I'm working with job completion, if the first part of a project I was supposed to have worked at this rate, and then the latter, but I went too slowly, and so now I had to work at 2 different rates at the beginning and the end of the project, I can also treat those as what was my rate at the beginning, what was my rate in the second half, and then what's my combined rate. Yeah. Well, and traditionally it's perfect, right? Like, that's perfect. As long as you see them as weighted average, you can 100% do this traditionally, right? I would still say I'd want to use not the 900. I wouldn't want to go through all the math with all of those pieces. But here I'd want to say, all right, I had a 25% markup on 9, and then I had a 45% loss on 1, and divide that whole thing by 10. You'll get to the exact same place. Yep, like the exact same place. It's no different. Totally the same. And so the biggest thing to take away is, 1, can I see the types of problems that are weighted average? If you want to plug them into a weighted average formula, by all means, just make sure you reduce the weights. Make your life easier reducing the weights. Or you could kind of visually tug-of-war them. This is also the case, again, for problems like mixtures. Mixtures are generally weighted average in disguise. This profit loss average, like I lost some on this and I gained some on this. What was my overall average profit or loss for the entire shipment? Also fits here. And those weird job completion ones. So Terry had planned to read 90 pages, or this person had planned to write 15 pages per day. So that was their overall intentional rate. However, her rate in the first half was only 12 pages per day, meaning that she had to do 18 pages per day later on, right? And so how many days did she have to split those up? It's the exact same weighted average. Yeah. And so what I want to think about, right, is how do I recognize these? How do I spot them? Yeah, how do I spot them? All right. So I want to turn it over because these will also turn up in data sufficiency. And I think what you might notice is that one of the questions that I think comes up quite a bit is, how do I handle this in data sufficiency without having to do a ton of math? And the answer is, if you can understand, if I've got this and if I have this, I can definitely find this. Or in order to know this, I need these pieces. That's why I like the visual, right? I can solve for things where certain parts are missing, but only certain parts. And that's what allows me to set up data sufficiency without having to go through a ton of math. Yeah. So let me turn us over to some questions. If anybody's got any, I saw one. Yeah, I like Tug-of-War. I think it's fun. I think it's a nice visual because it can help me keep that mental math in mind. Because if I do too many, I mean, as you can already tell, my lord, if I do too much math in my head, like I am an actual disaster. And which I think for a lot of us, when we're tired, when we're stressed, when we're overwhelmed, when we're doing a lot, and that's part of studying, we tend to do worse with things that are just held in our head. So any way that you could get it onto your paper, the better. Yeah. So hit me with it. I know you had a few questions you were thinking of. I can stop sharing for now if that helps. But I know you had a couple questions you were thinking about, Harsh.
Yeah.
Oh. So we've got one. Can we solve that pages problem with a Tug-of-War? Yeah, we super can. We 100% can. How might you set it up? I want to hear from y'all. So let me put that. We can put the completion question back up. And then if there are other questions, bring them on in while people are kind of thinking about this one. How might you set it up? What might it look like? Yeah. So if we put this in, right? My goal was originally 15 pages per day, but I only wrote 12 pages per day to start with, leaving me 36 for the last 2. So these 2 days I did 18 pages each day. Right. And so we've got kind of this split here that Dana was supposed to have done 15 pages over the whole thing. She got 18 pages done on 2 days. How many days? So I can like look at my differences. If I have to come in 3 under and 3 over, how many days was she going to spend writing this report? Oh, so be careful. This was 36 pages for the last 2 days total. So usually they're going to give you, so it's not 36 each day. It was 36 total. So you generally for these papers one, but so notice this weight is the same, right? It's 3 on either side, which means this is going to be the same. And so she spent the exact same number of days she came under 3. And so then she had to come over 3. Mm-hmm. Yeah. But I like that because I can do that without a lot of math. I can kind of see it pretty quickly. Any other questions that are coming up as you look over some of these?
I have one question, and I think even after reading the first question today, I think most of the times it's so difficult for some of the questions to be identified as a weighted average one, and we just start solving algebraically in a traditional way, correct?
Absolutely. Absolutely.
So generally, most of these questions, what I've seen, takes like 3 to 4 minutes. But if you know that okay, this can be solved by a weighted average, it might cut down your time by half, kind of thing.
Yeah,
So
for sure.
How do you identify that okay, this could be solved by weighted average, and maybe let's say I have already spent like 30 seconds, and I know it's gonna take me like 2 more minutes. Should I kind of reread the question and try to understand, is there a different approach, or just stick to what I have started doing?
Yeah, it's a great question. So there's sort of like 2 questions I'm hearing, right? So the first is, how do I tell, like, what are the signals to me that it's weighted average? And so this is the piece that I want to highlight. So let's bring in, I'm going to back up a couple. So let's go to the more obvious ones, right? So maybe the lawyer or the high schoolers or the student scores. The first thing that you want to be looking for when a question starts to talk about there being 2 groups that are getting combined or one group that's being subdivided, right? In any concept under the sun, no matter what they're talking about, right? Like if I'm like, oh, the first half and the second half, oh, the first group and the second group, the juniors and the seniors, the this hour type of hour and that type of hour. Anytime they make it very clear that there's two parts and that we also consider them as parts of a whole. Now, there'll be some places where I'm not going to apply weighted average here. So most of the time I'm going to. The very few exceptions would be things like average speed, right? So average speed is a tweak on weighted averages. It technically is a weighted average question. It's just that when you weight speed, when you weight anything, especially if that thing you're weighting is a rate, right? Like, so we were looking at height. That's just a metric, right? It's just plain old height. But if we started to look at something like $375 per hour, $225 per hour, so these are technically a rate, we're going to weight it by whatever that per unit is. So in 90% of cases, it's going to set up really nicely in this over under because you're going to be weighting by the natural weight. Like in this case, I'm weighting by the amount of time, the number of hours, right? Because they're asking for it really cleanly. It gets a little weirder, and it's why it's a little harder to see when they start talking about percentages, because it's like, wait, it's a percent of, profit as a percent of total cost, right? It's a profit as a percent of. So why is it okay that we're just looking at the number of laptops here? Because the cost is the same for them all. Their cost basis is identical. So we can think of the number of laptops here as equivalent to its cost. Like its unit cost is one laptop, right? I don't know what that real number is because I don't want to go back and back it out. I can just think of it as one laptop. Where that gets messy with speed, because speed is still like average speed. Like if I traveled at 40 miles an hour on the way to a place and then 60 miles an hour on the way back, there's this desire to call the weighted average, since I went the same distance, like, oh, wouldn't that weighted average should be right in the middle? But think about what a speed is. It's kilometers per hour. And so the weight there isn't distance. The weight is time. And so because that's kind of weirder in those problems, we generally don't apply this over-under metric. We just use the average speed formula. Another place where that, and like Harsh and I talked about this earlier today, are these dilution problems, where you might see them where we combine some amounts of like juice or milk with free water, and then we resell it at a new price. Like that still looks like it's this, okay, now what's the new? It's like a mixture, except the problem is that now we're sitting in this world of, we're looking at profits and revenue, and so we're not actually just blending profit and profit. Right? Like we're trying to convert from a profit to a revenue, and so they don't quite fit in the same format. So most of the time, the vast majority of the time, if you've got two groups and you're being asked, okay, here's metric X of this group that we care about, and here's metric X of this group that we care about, and we're alluding to metric X for all of them together, right? That's the trio. That's why I like kind of this look, right? I've got the group, a group, and everybody in the middle. If I can fit it into that sort of mental framework, it fits into a weighted average. Mixtures do that because I've got like percent of saline when I bring them together. Profit and loss does that because I have the profit loss over under, the combined profit loss. It works for an effort. I was supposed to read this number of pages, print this number of pages, do this number of work over a whole period. I did some of it in the first half, some of it in the second, however much. It's the same piece. So certain elements have just like a really famous tell. So again, mixtures almost all of the time on the GMAT, with the exception of those dilution problems, mixtures fit directly into this format. Work, like scheduled work, directly into this format. Anytime that we're trying to do a profit loss in this way, directly into this format. And then anything that's that more generic story problem of, the heights of this group and the heights of that group and the heights of them together, their salary, right? Like that piece. So we're looking for those elements. You can usually find them within the first 15 seconds of reading the story. If you can illustrate it this way, which is again why I just love a quick, because it'll help me organize my information. If I can organize it this way, I can solve it this way, right? hands down. And so for data sufficiency, even that makes this really nice because I can collect what I know and I can see very clearly what pieces of information are missing. If all that's missing is the middle, I can solve for it. If all that's missing is one of the weights, right? So a missing subgroup average, I can solve for it. If what's missing is one of the weights, I can also solve for it. If what's missing is both weights, I can solve for proportion, but I can't solve for actual number, right? I can get the ratio of 2 to 3, 1 to 5, but I can't figure out, so I can say it's like 1/6 or 2/5 or whatever, but without a real number, without one of those two values being known or like a total being known, I can't, right? Like I can't get an actual number for the weights or the amounts, but I can get their ratio. So anything that I can jam into this thing, maybe it's a like lazy way of saying, if I can fit it into this image, I can solve it with this tug-of-war. I can solve it by visualizing, by reducing the weights, or in the data sufficiency purpose, I can just know that I can solve it, which is really helpful to save us a lot of time for the mechanics. Yeah. If I've been solving something, to the second like sub question you asked about if I've already started, should I just like keep going? That's where I would say to myself, is this algebra doable in under 3 minutes? Because if I've started down the algebra path and I'm working on it, fine. I'm on the test, right? We're in middle of test mode. If I'm on the like practice mode, however, and I'm like, this algebra is terrible, I'm going to stop. I'm going to take as long as I want because, and if you've worked with me or seen me before, like I'm a big proponent of timing every question you do with a timer that counts up so that I'm not cutting myself off at 2 minutes. I'm trying all the things to see how long it takes. And so you might say to yourself, I'm going to go look for questions. I'm going to grab my official guide. I'm going to go into GMAT Club and I'm not going to search weighted average. I'm actually going to go into GMAT Club and just start scanning through problems to see if I can identify things that might fit in this. And then I'm going to see if GMAT Club signaled them as weighted average, right? You're going to practice that recognition piece. Yeah, okay, so Jaival has a great question. This is a subtle difference, kind of like archetype. It's a little bit weighted average, the removing of someone, but generally the concept that the GMAT is testing here is, do you know that when you remove someone, you have to remove their kind of spread out impact? And so because we're only removing the one person, let's say I had 10 people originally. So I'll just kind of give myself a little screen to write on. Hold on. So somewhere here I have a blank one, I'm sure. There we go. All right. So if I were to have, 10 people have an average salary, let's make them, let's $60,000. Right, something simple. And then I remove one person whose salary was $75,000. Right. What's the new average? The thing I like to do in practice is see that we're not really weighted at, I mean, we're saying the 9 people had some weight that I don't know, right? So this is my 9 people. So we can kind of set it up over here. My 9 people have this like weight I don't know. The one person has this $75,000 weight. Yeah. And so this guy's going to pull 9. This one's going to pull 1. The average was 60. And so I can still use that kind of same impact here to pull it out. There's also another way you can just kind of subtract them from the total by subtracting off like what their spread out impact is. But either one. So if you start to feel more comfortable with this over under, you can still get there this way. Because it is looking at one person as their own subgroup, 9 people as the other subgroup. And so one person, right, moved this kind of needle, 15. And so I've got to figure out what the other end of it's going to be. That's 15. So that's exactly 15. That was, in fact, right. So this 15 is equivalent to 9. And then I would find that same ratio going the other direction. Yeah. Could have picked
I have
easier
one
names.
another question, maybe
Of
a
course,
little
yeah.
off
Ask
topic,
away.
but
Yeah, ask away.
but on the data sufficiency side, even there
Mhm.
we see like a lot of weighted averages. But there we have like two statements, and each would give us kind of a different kind of a ratio.
Yes.
So, what would be your advice in those scenarios to not get carried away after creating one visual here and then just
Yeah.
taking it forward with the other statement?
Yeah. So I think there's a really great example. I'll kind of put it up. I think one of the things, and this is one of the ones I think you brought up, um, is that when I ever have a story problem in data sufficiency, I am always going to look at everything first. I know that can feel a little dangerous, but I'm going to kind of look at everything first and see what they're giving me, because sometimes the clue to weighted average is in the statements. It's not up in the opening information. So I trust that y'all are smart and restrained enough that you can read all of the information, but only use certain information at a time. Right? So with great power comes great responsibility. So I want to read ahead, but then I have to continuously remind myself, if I'm on statement one, I'm only looking at statement one. If I'm on statement two, I'm only looking at statement two. So what I would notice in this problem, fuel A costs $4 per gallon, B costs $8 per gallon. We make some new mixture by combining the two fuels. Great, we're in a mixtures problem. Right, I've got that now. That's very clear to me that we're in a mixtures problem. And then they're asking me about a ratio, which means I'm already starting to think of what I need, right? Like I can think of my upfront information, and this first one is actually telling me the average cost. Here I've got, $4 per gallon, $8 per gallon, and then so this is my cost per gallon. So my number of gallons is going to be the thing down here. So I don't know what those are. And then the question is asking about this ratio, essentially. So in order to get that ratio, I'm going to think to myself, what do I need? I either need to know the middle number, right? I mean, I definitely need to know the middle number, or something that can help me get at that middle number, right? They either need to give it to me or they need to get me in that direction. I don't actually need either of these amounts necessarily to get that ratio. I just need this guy in the middle, which statement one gives me right away. It says the average cost is 6, which means, oh, I've got 50/50s. It's great, right? I'm going to have to compare that against this number, but it does at least give me enough information to figure out the precise ratio, which would then answer that, right? So the precise ratio is either going to be, yes, it is more than that, or no, it's not, right? So if I know that the average cost per gallon of mixture M is 6, then it's a 50/50 mix. I have an answer, sufficient, right? If the answer is no, there's not more, but it's still sufficient. If the cost of 5 gallons of mixture M is greater than 28, okay, that's the total cost. I need to put this in gallons, right? And price per gallon. So it's 28 over 5, and this one is, right? So this means that this is going to be 3/5, so like 5 3/5, or $5.60. So it's greater than $5.60. So now it's like, well, I'd have to test a few. And I'd want to look and see what's going to be 60 versus 40. Like, where would that line need to be for me to have 60 versus 40? And then I can answer it. But I can still get my visual up and see that I'm in weighted averages kind of first. I can already start to see what information I would need because I know what's allowed to be missing. And it makes life a little bit easier to solve. I don't have to draw 6 of these, right? I don't have to draw it a million and do a bunch of math. Hopefully that helps.
Yep, super helpful.
Yeah. Well, I know we're over by a minute. If there are any other questions, by all means, like please let me know. And then again, if there's any more help that you would like, I'll put up my contact information. Feel free. I've got free one-on-one sessions. Just come and sit with us, right? We're here to answer your questions about anything. So this is not a sales call. This is you coming to talk to us about whatever it is, like what you need help with your study resources that you're already using. Help you review a practice test, whatever the case may be. Feel free, jump on our contact, come hang out. As always, it's been a super pleasure to get to hang out with GMAT Club. Maybe schedule with me like after 7 a.m. my time. So we can meet early morning your time when I'm more awake. But thank you so much, Harsh, for having me. And thank you to all of you for being so involved. I appreciate you so much. Thank you.
Yeah. Thank you, guys. See you again in the next one. Bye.